Hi there, you're welcome back to my channel. In this video, I'll be taking you through iterated integrals. In multiple integrals, it starts with double integrals. Then under double integrals, we also start with iterated integrals. What do I mean by iterated integrals? Iterated integrals are integrals over a rectangular region. So you have a rectangular region which is represented as R, given as A, comma B, then C, comma D, sorry. So these coordinates represent the regions on the X and the regions on the Y, the boundaries on the X and Y. Okay, so if you have a function on the X and Y axis, the boundaries of the function on the X and the boundaries of the function on the Y gives our rectangular region. Whenever you are doing iterated integrals, you only have to take care whether you will integrate the X part first or the Y part first, right? You can have integral AB, integral CD, right? So always the one that comes first represents the X coordinates, then the one that comes last represents the Y coordinates. So if I do integral and I bring my X coordinate outer and my Y coordinate inner, it means that I'm going to integrate with respect to Y first. Okay, so f of x comma y, then I introduce my dy dx. So you first tackle what is inside first before you go outside. Okay, then you can also change this and you make your the x go inside and the y come outside as well. So you can bring your CD here, then you bring your AB here, then here becomes what? The x, then here becomes the y. As simple as that. As simple as that. So you just have to change this side to the s, then bring this side to the y. So the x, the y. So now I have two problems for us to see through. So the first one, let's get straight to it. So my A part is here. So double integral over a general region R, rectangular region, and the function is 1 over the expression 2x plus 3y all squared dA. Okay. Then the rectangular coordinates are R, which is equal to 0, 1 times 1, 2, being the dimensions of a rectangle. Okay, so now the only challenge is we ask ourselves, what are we going to integrate first? Okay, what are you going to integrate first? So with here, what you do is, I think with this function, anyone we choose is going to be the same as difficult as what as the other. When you integrate x first and y first, they're almost the same. So we just have to integrate x first. So integrating x first, you introduce your limits and your y should go outer. So 1, 2. Since you are integrating x first, x will come inside 0, 1. Then our function will come 2x plus 3y everything squared, right? D. So now the area will now become what? X times y. Why? Because you are integrating x first, right? So the x, y. Having done this, you're almost done. You're almost through with your integral. So at this point, you know that you are integrating with respect to x. You know this is just integration using substitution, right? So you have to make substitution here, and when you differentiate what you have inside here, so let u be equal to 2x plus 3y. That's all. So the u on the x will simply be equal to 2, right? But my du will be equal to 1 out of 2. Sorry, my dx will be 1 out of 2 du. So if I want to remove this dx, I will have to introduce my half there. Okay, so my inner function, so let me introduce the outer and the inner. So I'll have 0, 1, but here I'm going to get my du, the x is now 1 out of 2, so let me bring a 1 out of 2 here. Then I'll have 1 over u squared, then du. As simple as that. Then I'll bring my dy. So having done this, you know that this is the same as u to the power negative 2, right? So if you have u to the power negative 2, when you integrate this, you add 1, making u to the power negative 1. Then you divide through by what's negative 1. Therefore, our integral simply becomes 1, 2. Then let me introduce, I've integrated this, so I'll have u to the power negative 1 over negative 1. So the negative 1 will affect our half here, making negative half u to the power negative what 1, right? Then you introduce your limit 0 1, then you bring the y out. So as simple as that. So we are done with our first integral. We only have to make the substitution. But to make the substitution, remember u was not given the portion. You have to make you have to bring the right um, function for u. So we said u was 2x plus 3y, right? So we're gonna have 2x plus 3y to the power negative 1. Then we are taking 0 to 1 of this expression y. So when 1 goes into it, what are you getting? And when 0 goes into it, so when you get 1, you know that 1 plus what? 3 times 0 is what? So you get 2. Then 2 multiply what? Okay, this is actually an inverse something. Okay, this is actually an inverse. So let's see what happens here. So we put 1 inside. So when I put 1 inside, I'm having expression 1 over 2x plus 3y, right? So at this point, I'm going to put 1, right? So I think at this point you're only making substitution for x, right? We are only dealing with x and not for y, because y is not the variable we are considering, right? So when I make my 1, when I put 1 is, I'm going to have 1 over 2 plus or 3y. Is that not it? 1 over 2 plus 3y. But remember, I'm having this negative half here, so let me maintain that. So what you do is, let's push everything outside. So you're going to have this negative half outside, then integral 1 to 2. Then our inner function now becomes what? 1 over 2 plus 3y for the one part. Remember, when you put in 0 for x, you get what? 1 over 3y, right? So that was going to give us minus 1 over 3y dy. As simple as that. So now we are left with what? A function only in what? In y's, right? A function only in y's. So at this point, as we are having this, everything is in y and you are integrating with respect to y. So what do? We simply take the integral on, separately, okay? So using the principles of integration, you're gonna have 1 to 2 of what? 1 over 2 plus 3y dy minus integral 1 to 2 of negative 1 over 3y dy. As simple as that. So we bring our negative half outside still. This becomes, we're integrating this with respect to y. Remember, you also have to still do substitution, because when you integrate this, when you differentiate it, you get on 3, right? So that's going to give us reciprocal 1 over 3, right? Then the whole thing will become natural log of 2 plus 3y. You need to get your integrals on your fingertips, so whenever you are doing this, you don't have to stress yourself. Whenever you are doing natural log and you have variables, try to bring absolute to account for any what's negative input. Okay, so once you get this expression here, then you have minus, this side is going to give us also 1 over 3 ln y, right? 1 over 3 natural log of what? Y. Okay, then we introduce our 1 to 2 as our variables up there. So now I'll have to factorize 1 out of 3 out. So I'm going to have negative 1 over 6 as outside. Then I'm going to have my function be 1 natural log of what? Absolute of 2 plus 3y minus natural log of what? Y, right? 1 to 2. 1 to 2. So at this point, what do? Remember something here. When you are doing the properties of natural log, when you have two logarithmic functions which are simply, the difference here, we can apply log here, right? We can also apply log here whenever they are added. So we can simply do it this way. Negative 1 out of 6, natural log of 2, right? Then this becomes okay, so let's make it this way instead. Okay, sure. So we want to make our substitution, all right, but we have this expression here. So the natural log of this whole expression on the natural log of this whole expression. So let's make our substitution first and see. So natural log of what? 2 plus what? This our y is what? We are putting 2 first. When I put 2 inside, I'm going to get what? 6, right? 6, right? So absolute minus natural log of what? I'll just put 2. Natural log of what? 2. Then minus the expression, I'm going to put 1 inside. When I put 1, I'm going to have natural log of what? 2 plus 3, which is what? 5, right? Then minus the natural log of what? 1, right? Log 1, natural log of 1 is 0, right? You don't have to focus on that. So you just have to clean that there and see what happens, right? Okay, so let's see. Okay, so finally, let's write our answer. So minus natural log of 2. Then, as I said, when I put 1 here, I'll get natural log of 1, that is 0. So you are not interested in what that, right? So let me end here next. So when I have at this point, what do I have at this point? No, I think I have something. When it was minus natural log of 5. So let me, yeah. So I think I had here, when I put the 2 here, so when I put the 2 here, I'm getting 2 plus 3 times so. So when I put the 1, 2 plus 3 plus 1, that's so it gave me natural log of what? 5, right? Natural log of 5. Then when I put the 1 here, I'm going to get 0. So I'll maintain this. So this simply negative 1 out of 6, natural log of what? 8, minus natural log of what? 2, minus natural log of what? 5, right? As simple as that. So that is for the first part of the problem. We had a second part of the problem as well, and that was double integral for, so that was double integral over a rectangular region x e to the power xy dA is equal to, so here our region was given as r is equal to negative 1 comma 2 x 0 comma 1, right? So now when you have this, as I said, you have to choose any of them first. So our x coordinates are negative 1 2, and our y is what? 0 1. But you realize that looking at this function, you realize that when you integrate x first, it's going to be quite difficult as compared to integrating y first. So what do you think? We just have to integrate with respect to y first, or we put y as what? Our inner function. So negative 2, negative 1 2 will be out, and 0 1 will be inside, and I'll have x e to the power xy, right? Then dy dx. Okay. So simply, if you are integrating it with respect to y, you know that when you use your exponential form, when you let u is equal to xy, right? When you differentiate u, remember you get x, right? And in integral, you divide by what? You divide the expression by x. So if you have negative 1 to 2, then here you are going to get e to the power what? X, y. As simple as that. Then we introduce our limits 0 to 1, then our dx will come out. As simple as that. So negative 1 to 2 of the expression here, when I put 1, I'm getting what? E to the power what? I'm putting 1 to y, so e to the power x. When I put 0, everything what? 1, right? When I put 0, everything is going to give me 1. So minus 1. Then everything here, dx. So right now I have a function all in x. I simply integrate with respect to x. And when you integrate e to the power x, it's still e to the power x. When you integrate 1, it's x. Negative 2, negative 1 to what? 2. you just put your function, you get e to the power 2 minus 2 minus, now I'm going to put negative 1 inside, so minus the expression e to the power negative 1 plus 1, right? So e to the power negative, e to the power 2 minus 2, then this becomes minus 1 over e, right? Then as you know, here is what, minus 1. Simple as that. So minus 2 minus 1 becomes e to the power 2 minus 1 over e minus 3, as simple as that. So that's all I have for you in this video. Thank you for watching, and don't forget to subscribe, share.